Hello, everybody. Welcome to Women in Coding and Data Science webinar. I would like to do a quick sound check before we start. So if you can hear me. So if you can hear me, please type yes in the questions tab. Okay, so I think everything is good. Hello and welcome, everyone. Thank you for joining us today for our webinar. My name is Parul and I'm one of the co-founders of WICDS. I'd love to start off by introducing our speaker, Huifang. She is a data evangelist with Atoti and has been reaching out to the community with various data analytics use cases. Prior to her current role at ActiveViam, she worked as a senior business analyst and IT project manager in a financial institution. Before I hand it over to the speaker, I'd like to go over the following housekeeping items. Please feel free to send us your questions throughout the session via the questions tab in your console. We'll be happy to answer them towards the end of the webinar. The webinar is also being recorded and it'll be uploaded on YouTube. Without further ado, I'd now like to hand it over to our speaker.
Hello, everybody. Thank you for taking some time off your Saturday evening to join us for this session. And thank you to Paru for organizing this event. Okay, today I'm going to take you through how we can create a BI analytic platform collaboratively on Google Cloud. So first of all, what do you know about a BI analytic platform? Okay, so what is business intelligence? Okay, from Google, what I found is that it is a self-contained architecture that enables non-technical users to execute a full spectrum of analytic workflows. So I summarize this in a few steps. First, the data preparation, okay? And we also have the interactive analysis. Lastly, we have the collaborative sharing of insights. So what goes under the data preparation, you say? Okay, first of all, the platform should be able to load and perform data cleaning, okay? And we should be able to integrate multiple data sources. So this will allow us to enrich our data to give more insightful informations, okay? So next, let's go into the interactive analysis. So for non-technical users, they should be able to do self-service data exploration. So this will include visualizations, well, let's say in pivot tables or in charts and maps, for instance. Okay, and they should be able to perform some simple drill down within their pivot table to explain the anomalies, for instance. Okay, next, we talk about new measures computations. So for instance, if you have the purchase price, and let's say you have the selling price as well, so we will be able to compute the margin made for a product, for instance. So we should be able to do computations such as this. Okay, lastly, which is the key aspect of a business analytic platform, because this is where we will share our findings with the business user, with the various stakeholders, for instance. So normally this kind of sharing come in the form of a static report or a dashboard. So nowadays it's very popular to use dashboard because you can actually interact with it. Let's say, for instance, your users will be able to apply additional filters, for instance, or to drill down into a certain granular level to understand their data more. Okay, so now that we have understand what is a business analytic platform, I would like to go through a demo use case to help you understand it more. Okay, so I'm going to just escape from the presentation, okay, and show you a Jupyter Lab that I have deployed on the Google Cloud in advance. Okay, so what I'm going to show you now is using a Python library called Atoti. Okay, I'm going to first of all import the library. And notice here, I'm going to create a configuration on port 9999. Okay, so this is the port that I'll be serving my web application from. Okay, and here I also define a metadatabase for which I'm going to persist the dashboard that I will create later on as well. Okay, so I'll pass this configuration as a parameter into my Atoti session. Okay, so I'm creating a session here. Okay, let me introduce to you some of the data that I have online. Okay, so here I have data such as the currency, product, sales, and shops. Okay, it's in the CSV format. I'm going to load the sales into my data store first. Okay, so let's take a quick look. I have a few columns here. I have date, shop, product, quantity, etc. Okay, and the sales ID is the key, unique key for all this data. So using Atoti, I'm going to call session.readCSV on sales.csv. Okay, and I'm going to apply a key called sales ID. So what this key means is that all the data that is loaded within this data store will be unique. Okay, so we can quickly load it and then we can view the first five rows of the data. So you can see that this syntax is very similar to pandas.head, where it shows the first five rows. Now, with just one data store, it is good enough for us to create a multi-dimensional data cube. Okay, so by calling session.createCube on the sales store, okay, so the sales store is my base store, okay, and I name this cube as sales. So you can see that now I have a cube with the dimensions, date, product, sales ID, and shop, and it has a corresponding level beneath it in red. Okay, so these four hierarchies here, levels here, happen to be the non-numerical columns in my data. So what happened? What about the numerical columns? Okay, so Atoti is smart enough to translate this into measures. So what happened is for every numerical columns, we have a mean and a sum measure. Okay, so before I show you some visualizations, I would like to introduce you the web application that comes with Atoti. Okay, so by clicking on session.url, I can now create a dashboard. And here on the left-hand panel, you can see what is within my cube. And by default, I can open up a pivot table. Okay, so what I'm going to do now, I'm going to pull the quantity sum, okay, as well as the amount sum, okay, and I'm going to just visualize this over my product, for instance. So you can see immediately, right, this builds up. Okay, so in the event that I want to view it by shop as well, okay, now you can see that the data is we can see the pivot table being formed very fast with product and shop. However, this would involve a lot of scrolling, right? So I don't really want this. So what I'm going to do now is I'm going to drag the product across into the columns. Okay, so now here we have. Okay, so I have the shops by the product quantity. Okay, now I don't really want to view so many data, so many products in one go. What should I do? I'm going to add in a quick filter whereby it allows me to filter by the shop, for instance. So let's say I have a shop filter here. Okay, so this will allow me to view the products for a particular shop or multiple shops that I want to compare them against. Okay, and I can also add in more filters, for instance, on the product itself. So for instance, now I only want to view, let's say I want to view bed 0. Oh, okay. So let me just remove my filters here, for instance. Okay, shop 0, for instance, I have bid 24, 26, I have 46. Okay, sorry, because the screen is a little bit zoomed in, so it looks a bit scary. Okay, so let me just organize my data a little bit so that it looks nicer. Okay, so if I want, I can toggle this into a cluster chart, for instance. Okay, and I can give it a label. So let's say the amount per product type, by product type. Okay, and then now what I'm going to do is I'm going to save this dashboard. Let me call this dashboard the sales analysis, for instance. Okay, and then I'm going to save this dashboard, sales analysis. Okay, and now let me just quickly do a refresh. It's there. Okay, I'm going to now open up a tab in incognito mode. Okay, imagine you want to share this dashboard with your peers. Okay, so this is what we will do. Okay, just copy the URL, send it to your peers, and they will be able to visualize, they will be able to access the same dashboard as you. Okay, so if you take note of the URL here, the last 4 characters is actually the ID of this dashboard. Okay, let's go back to the Jupyter Notebook. Now that we have seen how you can create a dashboard quickly, and then you can perform some simple filtering as well as do a dashboard sharing, let's go a little bit further. Now, suppose sales itself is not very interesting without the product information. So now we want to enrich the data further. So I'm going to create a data store for the products as well. Okay, so I have quite a few columns as well. What I'm interested in is actually the purchase price in this case, and product is my unique key. Okay, so if I go back to the notebook itself again, now instead of using read CSV from the session directly, I will read it into a Panda data frame. This is just to show you that Atoti can manage different data source type. So CSV, Pandas data frame, you can have Spark data frame. We integrate with Kafka, JDBC. Okay, in the event that the type of data source that you want is not supported, you can always load it into a supported format, and then you can load it into Atoti. So in this case, we will use session.read pandas, where I set the key as the product. Okay, and I create the store name products. Okay, let's see. Okay, you see the data loading speed is very fast. And in fact, we can also use a data product store dot shape to have a look at the number of data that is loaded here. Okay, so now we have 2 data store. We have the sales store, we have the product store. What we are going to do, we are going to join these 2 data store just like how you would join 2 tables in a database. So I'm going to join the product store to my base store, the sales store, okay? And I'm going to join them using product to product. So these are the 2 columns that I have, right? Products here, and I have product in my sales store as well. By default, Atoti is smart enough to detect the common columns within 2 data stores and form this mapping itself. Okay, so here I'm only putting down the mapping to help newcomers understand the schema better. Alternatively, you can just print out the cube schema here. And here we can see between the 2 tables, between the 2 data stores, we are joined by the product. Okay, so far I hope you are following. Okay, now we can also explore our data within the Jupyter Notebook using session.visualize. Now I'm going to show you when I have the new products table data store, I can immediately visualize the average price. Let's say I take the amount mean here, and then I add in the subcategory. Okay, let me add in category first. And then I can actually pull the subcategory in, and you see immediately I can have a drill down here. Okay, so let me quickly go back to your friend, your colleague's dashboard. So this is the view incognito mode, right? So imagine this being your friend across the globe in somewhere in another state or in another country. Okay, so now if I were to refresh this, okay, it will bring me back into the view. And then here immediately, I'll be able to see the brand, category, and subcategory that we see earlier on. So here we see an online collaboration whereby any changes that is made to my data cube, okay, will be reflected across the web application, and all your peers will be able to access this new data as well. And remember here, we didn't do any restart at all. Okay, so it's all real time. Okay, let me just remove this. I only want it at the subcategory level. Okay, I can easily toggle my pivot table into a clustered chart. Okay, and then now I can perform a sorting to see which one has the highest mean. I'm going to quickly publish this into an app. Okay, let me open up my app here. Okay, so this is the sales analysis that we just created. What I'm going to do under widget, this is the widget that I have just published. I'm going to pull it in, and note here, we see only one value. That's because we have quite a few filters here. And let me, in fact, I want to remove this filter, and I want to remove the shop filter. Okay, I'll leave the shop filter, and then let me just add in a product category. Okay, I'm just going to add in my category. Okay, so that now we can actually, I'm going to just change my display into a checkbox. So we see we only have 2 product category, either the clothes or the furniture. Okay, I can collapse this so that it will become bigger. And in fact, for the charts, you can easily zoom in to see a particular data that you are interested in, or you can just simply toggle off the data if you want. Okay, so let me just do a quick save on this one with Control S and go back to my Jupyter Lab again. Okay, so far we haven't really interact much with the cube other than visualization. Okay, so now we are going to do a little bit of Python programming by using the cube properties. So what we have here is the cube hierarchies, levels, and measures, which I'm going to assign them to a variable, okay, HLM respectively. So let's take a quick look at the cube again, okay, to understand what is a level, a hierarchy, and a measure. So here, this level here is called a hierarchy, and this is a level. So what we have below, the numeric values that we are interested in, are called measures. Okay, so if you look at the measures here, we have amount, quantity, unit, and contributor count. So basically, contributor count just tells you the number of records that contributes to this value. Okay, so what about the purchase price that I was interested in? Earlier on, we see the purchase price. So Atoti doesn't create the measures for reference store. So in this case, right, product is the reference store and sales is the base store, right? So we have to create the purchase price ourselves. So let me quickly do the purchase price dot value, where it's actually Atoti dot value, and I'm looking up for purchase price in the product store. Okay. And once I have this purchase price, I can derive more meaningful measures. In this case, the cost price. Say, for instance, right, I have quantity. I know I have quantity sum. Okay. And then now I have purchase price. If I multiply these two at the product level, I'll be able to get the cost price for my products. Okay. So now I can quickly do a visualization again, where I'm going to pull in my product and I'm going to add in my cost. Okay. So you might say, well, knowing the cost price is not interesting enough. Okay, so what I'm going to do, I'll take my selling price minus my cost price to derive my margin. Okay, and then here again, you'll be able to see margin. And we can also look at the margin rate to know which product gives you the highest return, right? So let's look at the margin rate here. Okay, so again, you can easily perform a sorting to see which product gives you the highest margin or which product gives you the higher return margin rate. Okay, so let's go back to your friend who is on the other side of the world. Okay, now you can see here immediately I have the cost and I have margin and margin rate. So any new measurements that you created, right, can be accessed by your peers and then they can validate it for you as well. Okay, so this is the online collaboration that we are talking about. Okay, so now we have covered the measures. We can also do a visualization where, let's say I want the products and I'll get the margin rate as well. And we'll look at the products with the highest margin rate, the top 10 products. Let's say I pull the products into the filters. I can go into advanced mode whereby there is a lot of filtering criteria that I can have. So in this case, I'm going to choose top 10 products with the highest margin rate. Okay, and then I'm going to just apply my filter here. Okay, so this is not very interesting again. I'm going to convert this into a clustered column. Okay, so now I have my products. Okay, so I'm going to just sort it by the margin rate. All right, now we are done with the measures. Let's take a quick look at the hierarchies. Okay, so what are the hierarchies that I have here? So I have the date, product, blah, blah, blah. So I'm going to focus on the product, the categories, and the subcategories. So if you realize just now, we have been playing with levels, single level. So now I'm going to create a product tree whereby there is the category, subcategory, as well as the product level. Okay, going back to my hierarchy again, you can see now I have a product tree with three levels here: category, subcategory, as well as the product level. But what does this mean? Okay, what does this hierarchy do? Let's do a visualization to understand this more. Okay, so if I go back to my pivot table, now we will see a product tree here. If I add this in, and let me add in the unit price, quantity, purchase price, and oh, sorry, I don't want the purchase price. I want my margin cost and my margin. Okay, so now if I were to drill down to the subcategory level, okay, you will see immediately the subcategory values are computed on the fly. And I can zoom in further down to the product level as well. Okay, so this is what we can do with the hierarchy, for instance. All right. So now I can continue to load more data to enrich my data cube further. And then I can create some more complex measurements such as cumulated amount, whereby this will allow me to say, for instance, if I look at the cumulative amount, I can say across the dates, and I want to visualize it as a line chart, for instance. Now, I have the country, which I just added in. I'm going to split this. Okay. Now I have this. So I can share this one, publish to app again. Okay. So now let me open this up, and I'm going to just add in my new line chart here. Okay. And I'm going to do a save. Okay. So I will share this with Paru, so that you guys can have a go at this dashboard as well. Okay. Now, now that I'm done with the Jupyter Lab, okay, I hope you have a good idea of what a BI analytic platform on the cloud can do for you. So just a quick recap, okay? So what are the benefits of a BI analytic platform on the cloud? Okay, first of all, we take advantage of the technical resources available on the cloud, such as the CPU, the memory, network connectivity, and storage constraints. So now you no longer have to worry about your local workstation as you do your development or your data exploration. Okay. Next, we are looking at one single source of truth. So you see we have integrated multiple data source together in one data cube, one in-memory data cube. And all the queries that your peers can make, right, are read-only mode. So this will ensure that the data are non-tampered. They are not being tampered with. Okay, so we also see the ability to add in new data source without restarting the queue. So now with this new norm of working from home, right, can you imagine if you do your analysis on an Excel, how many copy of Excel will be flying around, right, every time you add in a new data source, a new pivot table, or a new map, okay, a new charts, for instance. Okay, so now you have a centralized platform on the cloud where you know your data are, tampered proof, and then it's just one centralized source. Okay, lastly, in terms of collaborative sharing of insights, any new data or measure will be available to all. So you will be able to immediately build your dashboards and then share your finding and then validate the analysis, right, and correct anything upfront. Okay, so for non-technical users, right, they can easily drag and drop, add in the levels, add in the measures, and then drill in to create to understand the analysis. Okay, so now that we have gone through the benefits of BI analytic platform, I would like to open up to the floor for one questions. So, Paru, if you may help me with this. So, can any one of you name one expected functionality from a BI analytic platform? So you can answer this in the Google spreadsheet that Paru will share with you, or on the LinkedIn message. Okay. Well, so now that we understand what is a BI analytic platform, I shall move ahead to look at the platform deployment. After all, today we are talking about cloud deployment, right? So what is platform deployment? What are the tools that we used just now? Okay, you have seen me using Jupyter Lab to show you how I can create a session with Atoti. I can read the data into a data store and then create a cube with it. Okay, so this, I use the Jupyter Lab to show you how we can explore data, how we can integrate data, and how we can create measurements. So in the prototyping stage, or while you're still doing your data modeling, so you need some tools to help you visualize. So Jupyter Lab together with the Atoti extension helps you to easily overcome this, to do a quick prototyping or to do your data exploration. Okay, so but in the event you are already done with your data modeling, you're ready to share, So you can ignore the Jupyter Lab, just extract your script into a Python script, okay, the Atoti Python script, and then you can deploy this on the cloud directly or on any on any server that you want. Okay, next we look at Atoti. So just now we saw that we created the Atoti multi-dimensional data cube, right? So this in-memory data cube will help you to perform aggregation on the fly, and then a BI web application comes with it. So this allows you to transfer your visualization from the Jupyter Lab into the web application, and it also allows your users to interact with the data cube themselves, create dashboards, whether they create it themselves or they access a shared dashboard. Okay. So of course you can choose other libraries such as Tableau. You can choose some other uh, other ones like Dash, for instance. But most of the time, right, you will probably need two libraries, right? So one to manage the data and one to manage the visualization. So in this case, to quickly demonstrate to you a BI, we use Atoti because it contains both the data processing and as well as the visualization. Okay, lastly, since we are talking about online collaboration, so we are looking at online platform clouds. Okay, so we have players such as AWS, Google Cloud, and Azure. Okay, so these are the three common ones that we can deploy Atoti on as well. Okay, now that we are done with this, let's look at the modes of deployment. Okay, in my use case, I have two types of deployment method. One, we can deploy using Docker, and two, we can deploy using virtual machine. Okay, so Dockers, right, you can deploy on cloud using either Google Cloud Run, AWS Fargate, and Azure Container Instance. However, in my perspective, right, when you're using Docker, although there's a little bit of debate here, some people might say that it's best to start to manage Docker images, right, at the beginning of your development, okay, so that you are in control, right? However, this means that you have to constantly update your image, and then if you deploy this on the cloud, it means that you have to constantly update your image into the cloud as well. So it's a little bit more hassle. Okay, so I would recommend this if you are almost production ready. Then you can deploy it on the cloud, and then your users can all access it together. Okay, so in the use case that I've shown you today, we are treating this BI platform more like a sandbox where you can go in and do your data exploration, okay, your visualization, data modeling, etc. And then you can share it with your peers directly as a proof of concept, for instance. So in this use case, right, I would recommend a virtual machine where you can deploy the Jupyter Lab. You can install any libraries that you want, Python libraries as you want, right? And then you can do your modeling quickly and share it. Okay. So for virtual machines wise, on the cloud we have the Google Compute Engine, we have AWS EC2, we have Azure Virtual Machine that you can try using. Okay. So now we have seen the mode of deployment, the tools that we are going to that we have used, right? I'm going to just quickly jump into the second questions that you can answer to win a book. So, can you name one advantage of having analytic platform on the cloud? Again, send your answer in on the Google form or on LinkedIn message. Okay, Paru, if you can help to put the question up. Okay, so please help to name one advantage of having an analytic platform on the cloud. Okay, now let's move on. Today we are going to look at how we can get this BI analytic platform onto Google Cloud. Okay, so I have used the Google Cloud with a free account. So let's take a quick look at this. Okay, I'm going to go into the incognito mode again. Okay, let me just open a new tab here. Okay, so you can easily create a Google Cloud account, right, for free with $300 worth of credits by simply clicking Get Started. So if you have a Google account, right, it's very straightforward. You just log into your Google account, click Next, and then everything is straightforward. Okay, so I will not go through this process. Okay, what I'll do is I will show you how we can create a virtual machine. Okay, and then yeah. Okay, so going back to the slide again. So these are the steps that we're going to take. We will create a project, okay, and then a virtual machine. We will need to configure the firewall. So port 88888 for the Jupyter Lab, and then 9999 for the BI web application that we have. Okay, the reason for splitting these two is so that you can open up the firewall 9999 for your users to use the BI web applications, and at the same time you can open up port 8888 for yourself as you do your data exploration on the Jupyter Lab. So this way you won't interfere with the structure of the data cube. Okay, next, since we are creating a virtual machine, we will need to install Python on it. Okay, so we can use the pipenv, or we can also download conda for instance. Okay, so next we will install Jupyter Lab with Atoti, and then finally we configure and we are done. Okay, so let me quickly show you how we can. Okay, so this is Google Home. Okay, so you can easily create a Google project by clicking here and then click on New Project. Okay, so here for instance, I can just say Atoti test. Okay. And then I'm not going to use any organization. I'll just click Create. Okay, so you can see that it takes a while for the project to create. Okay, here you can see it as well. So I'm not going to use this. I'll go back to the project that I've created earlier on to show you how we can use it. You see the project is created pretty fast actually. So here on the navigation menu, if you scroll down to compute engine, okay, you can find the VM instance. Okay, so if you're on a new project, right, you might need to instantiate the VM instance function before you can start using it. So in this use case, right, so Atoti BI you see here is the instance that I have shown you earlier on. So now I will show you how you can create a VM instance. So click the create instance here, okay, and then you can name your instance, let's say Atoti test BI. Okay, so select your region. Since I'm in Singapore, okay, I'm going to select Southeast Asia 1. And then I recommend you to choose 2 vCPU and 8 GB memory. Okay, so because we're running Jupyter Lab and we are going to host a in-memory data cube. So depending on the data volume, you can determine what is the size that is required. Okay, so now I'll just allow the HTTPS and HTTP traffic and create. Okay, voila. So as it will take a bit of time to create, right, I will not go through here. So in the meantime, let's look at the firewall. So here you can see that we can set up the firewall rules. Okay, so click on this. I've created in advance a Atoti BI ports. Okay, so you can click this to create a new firewall, a new firewall rule. Okay, so let's look at the one that I've created. So here the direction is ingress, and then I have opened it up for all the IP address anywhere. Okay, so you can actually restrict this based on your needs. Okay, and here on the TCP, you can see that I've opened up the firewall for port 8888, and for TCP, for the web application web application here, I've opened up a range of 10 ports here. Okay, so now I'm going to go back to the VM instance. Okay, and here we are done. Okay, now just now we mentioned that we are going to create a project, a virtual machine, and configure the data and configure the firewall, for instance. So the next step would be to install Python. Okay, this will take a bit of time to install, which I'm not going to go through. However, I have on my GitHub, right, the snippet to do this setup. So I will just share it in the chat group, okay, in the chat room for you. So you can just follow this, enter all this command to install Python using the pipenv. All right. And then remember, you need to set it on as a global. You need to make this as the default. Okay. So I will use the VM that I created earlier on, which already contained Python. Okay, so one advantage that I see of Google Cloud is the fact that I don't have to configure my own local SSH. I can simply come here and say open in browser window. Okay, so this will actually open up a SSH instance. Okay, where I can do my data processing. Okay, so while the SSH is loading, right, I would like to bring you to the medium.com Atoti. Okay, so on the medium.com/Atoti, I have an article about how you can deploy Atoti on AWS with Amazon EC2. Okay, so basically the functionality is the same. You install your VM, okay, then you set up your EC2 instance, and then you create the SSH. You set up your local SSH, for instance, and then you will need to install the Jupyter Lab. So in this case, right, for AWS, you can see that I downloaded Mini Conda, and then I use Conda to install Atoti, to create the virtual machine and to install Atoti here. Okay, so now instead of using Conda, I'm going to use pip. Okay, so now how are we going to set up? So for instance, now I'm going to, okay, let me just do a quick check to make sure that I have upgraded all my tools. Okay, let me know if you are unable to view the syntax. Okay. Okay. Next, I'm going to use a pip install Atoti together with the Jupyter Lab here. Okay. You can find the instructions to install Atoti on the Atoti documentation. Okay, so this is the Atoti website, and then you can easily access the documentation here. Okay, so here, for instance, I'm going to install using the Python package here. Okay, note on the documentation, right, I have an optional dependency here, the graph viz. So this is actually required only if you're doing cube.schema. Okay, you want to visualize the relationship across of your data cube, for instance. Otherwise, you can skip this installation. Okay, so it will take a little bit of time. Let me just double check that. Let me just zoom in a little bit. Okay, so while it is still installing, okay, let me just go back, toggle back. Okay, so back to the article here. So we have the steps. After we have finished installing the Jupyter Lab, right, we need to perform some configuration. So in this case, right, some parameters that we need to configure includes the IP address, whereby we want the notebook server to listen to all IP, and then not to open the browser after starting, because Jupyter Lab normally will open the browser by default once it's started. Okay, and Jupyter Lab comes with a default authentication, token authentication. Since we are deploying on cloud, it is a bit cumbersome to be passing the token around, right? So what we are going to do is we are going to disable the password and the token authentication later on. Okay, and then we will override the custom display URL with the IP address of your server instance, and then we will set a default root folder. Okay, so I'm going to skip this part here, and I'm going to jump over to the update configuration. Okay, let me see. Okay, it's still downloading at the moment. Okay. Okay. So far, do you have any questions that you might want to ask? You can ping it on the, I can answer any questions that you may have. Okay. Okay. In any case, okay, so here we see the external IP address, okay, which we will copy it later on for the configuration. Okay. Sorry, I'm a little bit zoomed out. Maybe I shouldn't have zoomed so much. Let me reset this. And okay. Maybe I'll just show you an instance that is currently running. Okay, so PS minus, let me just make this a little bit bigger. This is the instance that I have been sharing with you. Let me just kill the instance. Okay, so what happened is, sorry for the, okay, sorry. I'm safe. Okay, so now we see that the Python script has completed and we are done with the installation. What I'm going to do next is this. I will generate the Jupyter Notebook configuration here. Okay, and then let's go to the hidden folder and we will do a nano. Okay, I like to use nano, where here, right at the beginning, okay, I will just simply copy this whole configuration that we are going to change, okay, to add in. Okay, so here we can see for IP address, we're going to listen to all the IP, and then for password, I will just replace it with a empty string. Okay, so this will help to disable the password authentication, and then I will also set the token equals to an empty string as well. So earlier on in the firewall, you have seen that I've opened up for the port 8888. So I'm going to do the same. And here, the IP address. So we can grab the IP address again from the VM instance here. So I have the IP address here. Let me just copy it. Okay, let me copy this and then paste it. And it's being served on port 8888, for instance. All right, so now we are good to go. Let me just save this. Okay. And then what we're going to do next is this. I will just make a work directory. Okay, so this one is actually optional. You can choose not to do it, but I'm just going to Python copy the Atoti tutorial so that you have something to work with once the Jupyter Lab has started. Okay, so the next part is important in my perspective. Okay, I'm going to create a hidden folder for Atoti whereby I'm going to I'm going to create a config YAML file whereby I will have this parameter, the URL pattern. So earlier on, if you recall, in the Jupyter Notebook, right? Let me just scroll up to the top. Okay, here using session.url, we have this URL that helps to open up the web application, right? So this URL by default points to localhost. So we need to update this to point to the server instance IP address, right? Okay, so this is what this parameter does. Okay, however, note here in this article, right, I serve it on port of the port of the Jupyter Lab, and then I serve the BI port, right, on a proxy port. I serve the web application on a proxy port. So this is because I didn't want to open up too many port in the firewall. So in this case, right, I can just open up the Jupyter Lab port and then let the rest serve it on the Jupyter server port, proxy server. Using the Jupyter's proxy server, I can serve this port. So now let me just echo this, and then I'm going to go back and copy my IP address again. Okay, let me copy this, and then I'm going to serve it on the parameter port, and then let me just, okay, and then I'm going to output it into the YAML file. Okay, now let me go to the root directory, and we are good to go. So I can just run Jupyter Lab, and here, while it's starting here, you can see the URL access to load the Jupyter Lab. Okay, it might take a while. So the good thing about the using Google Cloud is this. So you can easily launch your instance by clicking on the URL, and then you do not have to set up a lot of things on your local machine. It's all online. Okay, and then here we have. So you can now access the tutorial and run through the notebook as what I have shown you earlier on. Okay, so now with this, I've completed the demonstration on how you can deploy the Atoti on the Google Cloud. Okay, you can do the same on the Amazon Web Services, AWS, by creating a free account as well. So you can check out the atoti.io website for the videos on how you can do so. So Atoti website has a lot of information. So in case you have any questions, you can always reach out to us via the various community that we have over here. Okay, so what is Atoti? Let me just quickly recap a little bit. So Atoti is basically a Python library that allows you to integrate all your data within an in-memory data cube and perform complex aggregations. And then you can perform your visualizations and then translate them into dashboard that is ready for sharing. Okay, so with that, you can also see the various features that Atoti offers. Okay, so with this, I come to the end of my demonstration today. So in case you have any questions, you can post it on the channel chat. Paru, I hand it back to you. Okay. Okay, I have a question. Can we create visualization with Plotly within notebook created with Atoti? Well, in fact, right, if we go back to the diagram here, to the chart here, this underlying, right, is actually the Plotly chart. So at the moment, we are integrated with a few types of charts here. So we have the line charts, area, etc. Okay, and then we have the pie scatter plot. So it's evolving at the moment. So more charts may be added later on. So we'll see. However, it is also possible for you to perform queries and then export the data into a Panda data frame. So from a visualization, say for example, in a pivot table, you can right click and then you can say export to CSV. Okay, or alternatively, we can also do a cube dot query, okay, where we can, let's say I'm going to query the margin. Okay, and then over the uh, let's say for instance, let's say I just put a margin M. Okay, so let's do a quick test. So this is actually a Panda data frame, so I can also add in more levels. Okay, so in this case, let's say for instance, I'm going to look at the product level. Oops, sorry. Right, let me just do a quick sorry. Mm, 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 mm. Ah, let me just double check on my syntax again. So if you go through the tutorial, you will be able to see how we can easily do the query. Let me just, okay. Okay. Say for instance, if you want to look at this, the quantity sum, okay. Usually I use the visualization, so that's why I'm not very good with the querying. Ah, did I? Mhm. Okay. Did I accidentally kill off my demo? Okay, let me just restart my kernel. Okay, in any case, when we do a cube query, right, we can actually output the data into a Panda data frame whereby you can use it to visualize in another visualization tool if you want. Okay, so Atoti, yes, Atoti works with big data. So in fact, right, initially our company comes up with a product that works with big data in Java Enterprise. Okay, so however, we find that the trend now is to use Python because it's easier to use, the syntax is easier to pick up, for instance. So actually, behind the scene, right, it's actually a Python wrapper over the Java Enterprise structure. So we are still we actually deals with big data in memory. So this means that if you have more data, you just need to allocate more memory so that you can handle the data resources. So this means that if you deploy it on the cloud, right, you can easily scale it to a bigger machine if you have more data. Okay. So what are the advantages of Atoti over Pandas? I would say they are a little bit different. Okay, Atoti and Panda, they can work hand in hand. Say for instance, if you are a machine learning engineer or you are a data scientist, let's say you want to apply some data learning algorithm. Okay, so this is not managed by Atoti. But what you can do is you do your machine learning, you have your output in Pandas data frame, and then you can load it into Atoti, and then your users will be able to slice and dice and visualize. And one of the biggest difference is this. Okay, if we are looking at a Panda data frame, right, most of the time it's static. It's a table like this one. Okay, you can't really interact with it. However, with Atoti, the visualization is actually interactive. So this means that we can easily toggle it between a chart to a pivot table, and then we can easily, let's say for instance, if I want to look at the brand, I can easily drag and drop, and then I can drill down as well. So at the moment, I think Panda is also evolving. I may not be most updated with their latest. So in this aspect, right, Atoti is slightly more user friendly, I would say, as you can just utilize the extension here to drag and drop and interact. And in fact, the very fact that we are integrated with our own web application is a big plus, because you can easily do your sharing instead of having to have another third-party library to do your visualization, your dashboarding. Okay, so uh, okay, let me share the URL of the Medium article. Okay, so Faru, if you can help me with this. Okay, so in fact, right, this article would also be available on atoti.io under the resources, so you can go under the articles. Okay, you can always reach out to me on LinkedIn or any of our community channels if you have any questions. Okay, so uh, let me just go back to my cube. So now here you see I can now do a cube query. So let's say I will just say this is a shop quantity. Let's say I'm going to assign this. Okay, so let me just do a head. So in fact, so if you do a query of Atoti, right, it will be output into a Panda data frame. So you can actually further utilize it with another third-party library out of Atoti if you want. And one more thing to add, Atoti can also be called from. So what happened is with Atoti, you created an in-memory data cube, right? So sometimes some users, they still prefer Excel. So you can actually invoke the data cube from Excel to have a pivot table within your Excel as well. So that is also possible. Okay, I don't see any more questions coming in. Do you have anything else that you want to ask? Okay, if not, Paru?
Yeah, so can you hear me?
Yep, now I can hear you.
Yeah. So there's this question, no? Does Atoti work with big data?
Yes. So I've answered that just now. Atoti is
Okay,
actually
okay.
meant to work with big data. So because the initial Java version, right, what we have been doing is we have been working with banks to handle their big data. So we can do actually like VAR calculations. We can do the MTM. Mark to market, for example, we can do a lot of data with vectors as well. So it all depends on the memory of the machine that is hosting the instance. Okay, so if you need to scale up your data, so you do your computation, your hardware calculation, and then you also scale up your virtual machine instance as example. Yeah.
So we just have a very quick question that just came through.
Mhm. Well, you can drop me. You can ping me. I can check with my colleagues if there are any opportunity at the moment. So of course, because our company also has many positions, like sales or like for myself, I'm a data evangelist. So we also have the R&D, for instance. So it depends on what kind of roles you're looking at. So yeah, drop us a message, and then if there's any opening, I will update you.
Thank you.
Welcome.
So I think in the interest of the time, we'll have to close the Q&A. I've also got a lot of replies on the quiz. Going to reach out to the winners depending upon their answers. And so now I'd like to thank the Atoti team and Huifang for this wonderful presentation and for taking out the time today and doing such a wonderful talk. I'd also like to thank everybody who joined us today. The presentation slides and the material will be made available on our YouTube channel, and also I'll be sharing it on the LinkedIn page as well. Have a great rest of your day and week, and thank you so much for joining.
Thank you for joining. Have a good weekend.